This video is on the unimolecular elimination or E1 reactions. Take this tert-butyl bromide reacting with ethanol. If I told you no more, you would probably assume it's going to be an SN1 reaction. And you would be right. We would get substitution to form this tert-butyl ethyl ether. However, it would only be 81% yield because you would end up with a side product, which is the E1 product. The rate of the E1 reaction is just like the rate of the SN1 reaction. The reaction rate only depends on the concentration of the electrophile. Hence it is unimolecular or E1. Turns out the reason these are mixed and we're not focusing only on the E1 reaction is because E1 only occurs when SN1 occurs. And SN1 only occurs when E1 occurs. So it's always a mixture of products. This is the reason why SN1 reactions are not as useful, or E1 reactions are not as useful in synthesis if you're trying to make what you want to make as it forms mixtures. However, where there's a will, there's a way for purification, so if you really have to do an E1 reaction, then so be it. The regiochemistry and stereochemistry of an E1 reaction also follows the Zaitsev rule. You're going to form a double bond that is more substituted. Stereoselectivity is a bit more tricky as we go through a trigonal planar carbocation, meaning we don't have syn or anti-elimination. We just have elimination of something of the adjacent carbon. This is most clearly emphasized with cyclohexane species, where trans-diaxial elimination is not required anymore. So we could get a reaction like this, where the conditions favor an SN1 reaction or an E1 reaction. Well, we would expect a mixture of products that follow the Zaitsev rule, as opposed to clearly 100% trans-diaxial elimination as expected in an E2 reaction. So in other words, if your conditions resemble SN1, if there's going to be elimination happening, it's going to be E1, and at that point, you just follow the Zaitsev rule and look for conjugation and draw your major elimination product accordingly. You have a go. What would the elimination product of the following reactions be? You may pause now. And here are the answers. So as we have clearly emphasized, SN1 and E1 occur at the same time, but we would ideally want to favor one over the other. Well, if you want to favor E1, you need a strong base as your nucleophile, you want to add heat, and you want some steric hindrance in your system. So in other words, you don't want your nucleophile to have a chance to access the carbocation. Whilst if you want to favor SN1, you want that weak base and no heat. To be honest, the telltale sign for an elimination reaction or a reaction that you want an elimination product to be your major product is that there is a sign of heat in your reaction conditions, i.e. there's a delta or a triangle around the arrow. Study these tables carefully. You can also find them in the textbook. There are tables 8.6 and table 9.1.